Assalamu alaikum. Today we will continue our integration using a new formula. So today we'll talk about Newton's codes open formula. What is the difference between open and not open? Closed. It was closed before. The reason is here, it was closed including A and B. Now we would like not included A and B. And the first well-known formula is called midpoint rule. What is it? You will take the one here in the middle, A plus B divided by 2 times B minus A. For this reason called midpoint rule. It can be shown that this is the error. Why is this important? Because imagine you want to approximate this answer here. This here, integration. If you take before trapezoidal rule or Simpson rule, which belong to closed formula, closed, it means you need f of 0. What is f of 0 here? Sine 0, no problem. But divide by 0 is undefined. You cannot divide by 0. It means the method will fail. Simpson rule will fail, trapezoidal rule will fail. So we need another method which don't use the bound integral. So like this one here. So like this one, for example, this one, if I want to approximate this one, just I will say the top one plus this one here divided by 2, the function value, and this minus this, and the answer is like this. Then just calculate sine this. Remember that here, this one here is approximation. We always should be approximation. Sometimes we don't write approximations. So here we approximate it even is undefined at once. It's called improper integrals. So we'll continue now, next slide, and see how to find out. How did we find that one? Well, here is the idea. So from A to B, okay, this is, imagine A to B, the answer will be like this. Summation constant times function value at certain point. And this one should be here, it says approximation, which is correct. It should be exact, equal when f of x equal 1, then x squared, x, and so on until we find all the unknowns. So like example for the previous one, we will talk about it later on, but now let's take it for simplicity between -1 and 1. So what is it here? If we start with n equal 1, so here is n equal 1, it means this integration should be approximated by this one here. This is approximation. So summation only n equal 1 here. So the answer is C1 if x1. So what is here? We'd like to know what is x1. So two unknowns. It means we need two equations. So the first equation, how to find here? Just you put f of x equal 1 as we said before. So it's 1. Substitute here, it means integrate dx from -1 to 1, and we know it is 2. And the right hand side, but f of x equal 1, substitute x1, it means 1. So C1, so here it is 2 equals C1, it means we found C1. Well, here, how to find x1? He did not say. Okay, I can write it down for you. So here, when we take from -1 to 1, again here now we have to put x, dx should be equal. Now again we have to write C1 x1. But what is it here? If you integrate this one here, what is the answer? Because this is odd, we call it odd function, and the answer will be 0. So now we have C1 times x1 equal to 0. Because C1, this is not 0, we found it 2. So this is not 0. So what will happen here? So this one here, not 0, it means we can't divide by 2. So this one equal 2, it means x1 equals 0. So we found x1 is 0, we found C1 is 2, and the answer will be, here it is, 2x1. So now we know which we call it midpoint rule. This is 2, which means 1 minus -1 is 2, and the one in the middle, -1 plus 1 divided by 2, it is 0. So this one should be, in fact, here x1 should equal, so this is really approximation, and this should be approximation to f, oh, why it's not writing, I don't know. Writing, but disappear again. To f of x1, I'll try to get some help. It's not writing here, again here, to f of 0. So this midpoint rule, just same as before. It was here, if we go to the previous one, so this is 2, it means this minus this, times this in the middle, so it means this one here. We can see it now, this here, B minus A, and this is in the middle, so now we know how it is. So this is called composite rule. And so this is the idea, so we now know how to derive this one. Let's go for more difficult one. N equal 2. Now I would like to repeat, but now N equal 2. How to do it? Well, as before, integration from -1 to 1, and we have the summation from 1 to 2. If you do this one, it means we have this. How many unknowns? Well, there are 4 unknowns, C1, C2, X1, X2. So we can see here they are. So how to find these values? So we have 4 unknowns. It means we need 4 equations. We'll start with the first equation like before. Put f of x equal 1. So here is 1. Integrate this one. We found it 2 like before. But the right hand side, f of x equal 1, what is this here? This is 1 and this is 1. So here is the answer. So we found the first equations. To find the second equation, put f of x equal x. Put it here. And we know the integration of this one is 0. The right hand side become here x1 and here x2 because f of x equal x. Put x1, it means x1. Put x2, it means x2. So we found here second equations. Here you write it again here. So again, one third equation, continue. Go for x squared here. You put f of x equal x squared. This is integration. Should equal here x1 squared, x2 squared. Left hand side, integrate it. You will find this answer. Very simple integration. Right hand side, here it is. Now x equal x cubed. This is odd function. The answer is 0. Right hand side, here it is. So we have now 4 equations. 1, 2, 3, 4. We need to solve them. How to solve them? Well, this should be easy to do so. And just like from here, I can know. I mean, this one, if you try to solve it without thinking, it will be difficult. But here, I like to start with this one here. And then, and also this one. So I go to next slide to show you how to solve this one here. So we put here this one equal this. When we put a substitute in equation 4, it will be like this here. When we substitute here, we got this one. And here x2 cube, well, assume is not 0. It means this c1 square equals c2 square. We solve it. We can find c1 equal plus minus c2. So take c1 equals c2. And later on, if you take c1 equal minus c2, you'll get the same answer. So now we know c1 equals c2. Put it in the first equation, which was, I'll show you too. That's first equation. C1 plus C2 equal 2. So it means now we know now this one here like this one here. So when we put it here, this substitute here, we found C1 equals 2 equal 1. Just go and substitute here. Again, you will find x1 equal minus x3. And then substitute in equation 3, here we are, because this equal this, we'll find here 2x1 square equal 3. And then here is the answer, plus minus 1 over square root of 3. So we know this one. Here is this one. So now here is the answer. So we know this one. We know this one. We know it's 1. And here 1. And here is the answer. This one called formula for how many? 2 points. Again, this is open formula. So let's just see how can we use it and integrate this one. So now here, if we substitute here Gaussian quadrature code, so just we have to put it this way. This is the page of things. So just if you want to approximate this one here, between -1 and 1, this is the answer here. Immediately at this value and this value. So it is equal at E minus substitute this value plus this one, we get this answer. If we want to do it like this here, look, divide by x here. Again, similar thing. But here we have, look here, this is 2. And this is 1. Well, we want it from -1 to 1. What can we do? Well, we have to change it. Either you memorize a formula. Myself, I don't like to remember formula. I write x between 1 and 2 and rearrange it. Like take -1, subtract here, it will be like this. So here should be this one. When you take -1, it should be here. This is 1, I think. And now multiply, yes, if this is 1, let me write it 1 here. So here when you subtract 1, so this is 1. Multiply by 2, so this becomes correct now. So this multiply by 2. And now subtract -1, we'll get this one. So now it is 1 right hand side, left one right side. And this one, we call this one t. And this is the answer between -1 and 1. Then the integration, this one here, becomes like this. From 1 to 2, dx over x becomes now function of t, dt over this, between -1 and, so between -1 and 1. Now we can apply the quadrature formula, which is the function here value 1 over square root of 3, 1 minus 1 over square root of 3. Substitute here, this is substitute here, plus this minus, and then when you calculate it, we found the answer. So it means we approximate the value. No need to go back and put it x, because here is the answer. If you want to do this one here, again, similar things. So you can calculate the error because it can be calculated. And continue in that way here. So for next slides. Again here, if you want to do so, the error can be calculated like this. If we want to do this one from 0 to pi, again, okay, we need open formula because divide by x, divide by 0. How to do it here? Well, this one here, we have to change it from 0 to pi. Nice exercise. It can be changed like this. So let this one t, it will be like this, function of t. Substitute now in that value, we will see, here we are. So this one here is equal like this, but okay, I don't mean it like this. So here we are, and substitute, we get a new approximation. And here, oh, be careful here, this is not correct. We don't know how to calculate this, so it's really wrong answer here. No, this is not correct. And here the error, no, it's not correct. We don't know how to find the error. Okay, so this is correct, wrong. So if we want to do here other formula like n to equal 3, well, here is the formula. You don't need to define it, just we'll give it to you. And it's given in the book for n equal 3, n equal 4, n equal 5, etc. Just you should know how to calculate it. Okay, so in that case here, it means we are, so there's no need here, we end this one here. So what is this formula for? It's really important because the error is, if we look somewhere, where is the error? It should be written somewhere. I'm just looking for the error. I cannot see here. Local truncation error, not exact error. So local truncation error, maybe it's given in the book. Anyway, so here is that. Now I will end this lecture now. So local truncation error, maybe it's given in the book. Anyway, so here is that. Now I will end this lecture now, and we will continue next week by a new subject.